Yeah, also welcome from my side. I'm Jürgen. I work for a company called Dynatrace. Anyone heard of Dynatrace before?
Of course.
Yeah, cool. Today I won't talk about Dynatrace. For those who don't know Dynatrace, it's a application performance management monitoring vendor. We reach into the topic of software intelligence with all the AI baked in our solution. But for today, I want to talk about our open source project started in the Dynatrace Innovation Lab, where I'm part of, called Captain, and how Captain and Ansible can be integrated and talk to each other, and how we use Ansible inside of our open source project, Captain. So what I want to kind of talk about, what maybe we want to talk about today, and I'm happy for questions also at the end. First, why we think we have to build this open source framework, why we have to build Captain, what actually is Captain, and then how can you build your self-healing applications, or just to be a little less bold, how to build your auto-remediation workflows with Captain and with Ansible. So let me start with why we have to build Captain, why we came up with the idea at the Innovation Lab, why we have to build Captain. And the reason for this was because cloud native delivery is a big challenge. And we have asked a lot of customers, and we saw that those customers, they pack their applications in their containers, and they run their containers in a orchestration tool like OpenShift or Kubernetes. We saw this before. Kubernetes it's a great platform, but it does not necessarily mean that they are cloud native, because for us, cloud native really means that it's delivering high quality software faster. So this is why we want these microservices. This is why we want to put our applications into containers to speed up the innovation and to speed up the deployments. But just to have these technologies does not necessarily mean you are already cloud native, but it means you have the tools for this. But there comes more to this. And we also asked customers, we started a survey and we asked them different kinds of questions, and we just took one here at this slide. What is their commit cycle time from development to production? How long does it really take for a code when it's developed and committed to their versioning system, from being pushed from development to production? And actually it took them quite long. So the median of the responses was like more than 2 weeks. It takes more than 2 weeks from a change in development to production. And only the 95th percentile, they were like fast, and by fast it's still 2 days. And within our organization, we were challenged a couple of years ago by our CTO to make it within 1 hour from development to production. And it took us quite a long time, actually more than 1 year. I was not at the company back then, but I know it took them back then a lot of time to improve all our processes internally. But then we finally made it to make a code change and to push it to production within 1 hour. Of course, we're not running all the tests there on this code base, but we are running the tests that we can still, we're still confident that we pass all these quality gates to make it to production. There are more results. I will skip them, but I just put them in there because if someone's interested, I can share the slides afterwards, and then so you still have some information there. And I would just go over this because I also want to talk about what is Captain, and then obviously how to integrate Ansible there. So Captain is really a framework for cloud-native continuous delivery and also for automated operations. So we try to solve like two problems, and sometimes we talk about launch control and mission control from the airspace terms. With launch control, we are referring to everything that you're doing to get this ship from the ground into the air, and you can always abort there. And with mission control, then your airplane is in the air. You cannot abort, you cannot just crash it, but you have to always try to keep it up and running, which would be your automated operations. What we have seen that a lot of our customers do and organizations do is they are building a lot of custom integrations into the pipelines. They might use Jenkins, they might have some Ansible scripts, they might have some test pipelines or testing tools, and they try to make everything talk together. And then but someone came up with this, what the iPhone could have looked like picture, because we still have a phone, but we also have a calculator, and we have like a camera, and we have a navigation system, and we have all these tools kind of put next to each other and made them talk to each other. This is also what we do, or what maybe most of us or some of us do in their organizations. We have a lot of different tools, and we try to make them talk to each other with a lot of custom integrations. And it gets very, very complex, and it's very tedious also to tear them apart. If you want to remove a tool, there are a lot of side effects. And this code becomes the new legacy code we see. But still, there has been a lot of effort to learn these tools, a lot of investment to maybe get these tools. It's getting very difficult to maintain everything, and this is why we came up with Captain, which is a framework where you can orchestrate all these tools, and you can really build your continuous delivery using Ansible, for example, and also to build your automated operations. So just let me show you what is Captain from a very high-level perspective. We are working very actively on this open source project, and it only started in January this year to being like when we created the first organization on GitHub, which was then called Captain. We started with a lot of learnings we did before, and a lot of learnings came also from what I've showed you, what other organizations do and our customers do. But then this year we really started a framework where we thought, okay, now we really have to put all our learnings into a framework which we can also give to customers, and where we can integrate other tools, where we can kind of start this, our ideas, and to really build a product which is completely open source. And these are some of our core capabilities. We have, everything is built on Kubernetes, so that's kind of a disclaimer. Kubernetes, OpenShift, everything which is a Kubernetes-based platform Captain is built for Kubernetes. So Captain has the core capability of providing multi-staged pipelines, and we also call them unbreakable delivery pipelines, because with Captain we already create quality gates for you in your services, so that your Captain can push your applications or your services from one stage to the other, like from a development to a staging to a pre-production to a production, by passing certain quality gates. And these certain quality gates are not just a couple of tests, but this can be like metrics from a lot of different metrics providers, checking response time, checking CPU saturation, checking memory of your services. And if the services satisfy the quality constraints, then they are being automatically promoted to the next stage. This can be also done with a blue-green deployment. So we are creating a new deployment for you in the next stage, testing everything against this, let's call it the blue version. If something is not satisfying, well, we can roll back, and everything is done with zero downtime. And we have event-driven runbook automation baked in, which means when you're already in production and something goes wrong, we receive an event, we can analyze the problem, and then we can start some runbooks, which would be most probably Ansible playbooks that can then remediate this issue. And this is also what I want to show you in a very short demo afterwards. We have a couple of design principles. So everything is stored in the GitHub repository. We are creating this repository to store all the configuration information, basically, of your services and your pipelines there. Your code still lives in your code repositories. Everything is defined as a code, so we are trying to define everything as code, so you are able to version this and also to change this by not taking a look into the configuration of Captain itself. Yes, and that's basically the most part of the bullet points. But let me just show you a little bit of the architecture, how we built this and how different services come into play here. So we can think of Captain like a control plane in your continuous delivery journey. And Captain takes as an input a shipyard file, and in this shipyard file, it is defined how your different stages would look like a development, staging, pre-production, production, or whatever stages you have in your organization, and which kind of tests have to be passed when you go from one stage to the other. Like you want to run performance tests, you want to run functional tests, you want to run end-to-end tests. So everything is defined in this file called shipyard file. And once you start onboarding your first services, of course, you need some internal Captain services to be executed to validate the quality of your services. And we already built some integrations with some tools. So of course, we have we need some services to talk, to read and write files from GitHub. We have a tool to talk to the container registry, which in our first implementation is Docker Hub. We have tools integrated for continuous delivery, so you can use your Jenkins or you could use Ansible. Also for automations operation, if you want to start playbooks in case of any problem happens in your applications or in your infrastructure. We have a Slack service, so you can have notifications of everything what's going on when you're deploying your services with Captain. You get notifications into Slack. Yes, and so on. And I want to show you how one artifact really goes through Captain when you're building the artifact, you're building your container image, and then you notify Captain about this new image. So this would be, you push the artifact to your container registry, you start your let's call it a Captain pipeline. You deploy. This could be, for example, done with Jenkins or also Ansible. Maybe there should be also Ansible logo. Maybe it comes later because maybe I messed up the animations here. But anyway, we run some tests. This could be Selenium test, JMeter, or whatever. And then we evaluate, which is also done with a component that is provided by Captain. It's called Pitometer. And here, everything is it is evaluated what you define in a file called a perf spec file, where you define the performance specification of your service, like it has to respond within 200 milliseconds. This would be checked here, then it would be automatically promoted to the next stage. The configuration in your GitHub repository would be updated to reflect that the artifact also lives in this case a staging environment. We can deploy it, and it would be the same here. All the tests are run. We would promote it, and yes, we could then here use Ansible for the operations automation. And what I mean by automation of the operation, I want to show you a quick demo. But before, let me talk about what we think of what are the basic building blocks for you to build auto-remediation workflows or self-healing applications. And these are basically two parts. First, you have to have in place monitoring, which doesn't have to be Dynatrace. It could also be some other monitoring. We heard the Grafana dashboards before and some other underlying monitoring solution. So you just need to be aware of what's going on in your application, in your environment. And on the other hand, you need some automation. You need to be able to automatically execute actions, like counter actions if something goes wrong. And in between, like the orchestration, as I showed you before, the orchestration can be done with Captain. Most obvious for the automation part, we are using some Ansible technology, and here I'm referring to Ansible Tower. We have not heard Ansible Tower today earlier, but who is using Ansible Tower? One.
And you're using the open source upstream version, AWX?
Okay.
Cool.
Yeah, Ansible Tower is, it's kind of a, maybe it's not here, no. So this is a screenshot of Ansible Tower, it's quite small. Ansible Tower is a management platform on top of Ansible. So it's, you have a nice web UI, and you can manage your playbooks there, you can build workflows there, you have role-based access control, you have your different projects there, you can store your credentials there. It's kind of a powerful tool when you want to automate and want to start playbooks like ad hoc from outside, because you have all these different APIs where you can talk to your Ansible Tower, and then Tower can execute or do whatever you want, but you have these APIs, which is pretty powerful for us. Yes, so this is Ansible Tower, and it just, for us, it runs those Ansible playbooks. And then we have this workflow, how it would look like in a auto remediation scenario. You have your application running in your production environment. Your monitoring solution here, the logo is Dynatrace, but you have to think of your monitoring solution is monitoring your applications, and it's checking for anomalies. So in this case, we are automatically checking for the anomalies. There is no need for setting thresholds. But if there is a need in your monitoring solution to set thresholds, think of it, you reach some threshold, you know that the threshold is reached, and in the best case, you also know the root cause, why the threshold has been reached. And in this case, a problem notification is sent out to another tool, to Captain. Captain is taking this notification. It then analyzes the problem by talking back to either the monitoring solution or to our service called Pitometer to check which metrics have been are the ones that are problematic for the service. Captain is then finding a remediation provider for all the remediation services that have subscribed to the Captain core. Captain then initiates the remediation, which is basically calling Ansible Tower to start a job. Then the job is triggered, the job is executing a playbook, and the problem will be remediated, which is this is what we want. And let me just quickly show you how we implemented this exact workflow in a demo application. And it's not a live demo, but it's a short video. And let me just start the video and pause it maybe every now and then, just talk a little bit to the video. It also has some annotation, so it's a kind of self-explaining, but in the video we used maybe someone has seen this before. It's a demo application. The company is called Weaveworks. This is called the sock shop, and we've just used this, and in this demo we specifically used the shopping cart service of this sock shop. So on the left-hand side you see a load generator, which is just adding socks to a shopping cart, just constantly adding socks to the shopping cart. Here we see just the Dynatrace product checking. Everything looks kind of good. Response time is okay. We see we just started the load generation, and now we are starting a playbook in Ansible Tower. And in the playbook, we start a promotional campaign by setting 30% of all the interactions with the shopping cart. They should receive a promotional gift into the shopping cart as well. So we are running this. Everything's fine, but on the left-hand side, we can see that the load generation now receives some errors. We will also see in the monitoring solution that first there has been a configuration change. So we know there has been at like today in the morning there has been a change in one configuration, which is basically a feature toggle, and Dynatrace or the monitoring solution will then eventually find out, hey, there is an increase of the failure rate, there is a problem. It will tell us, hey, there was a configuration change earlier, which was the root cause of this problem. It will send this information to Captain. Captain will then check, is there a remediation provider? Is there Ansible subscribed to the Captain framework so that we can start a playbook? If it finds this subscription, it will send the information to Ansible Tower, and then Ansible Tower would start the playbook. Actually, in this case, it will also talk back to our monitoring solution, tells the monitoring solution we just started the playbook, and it will also tell us when it's finished and if the action was successful. So we can see here on the left-hand side the load generation is fine again, and we can also see in Ansible Tower that there has been some more playbook started, which was basically just executing again this the same playbook with enabling the promotional change, but setting it back to 0. So this is a kind of a simple but yet powerful mechanism to write some counter actions for changes in your applications, because you can just how can I say? They are quite effective when it comes to resolving the issue fast, because when we take a look at the details of the problem, we can see that the problem only existed for about 5 minutes, and those 5 minutes were only needed because the Dynatrace AI needed some data to analyze what was the problem, why the root cause what was the root cause, and why the response time or the error rate in this case went through the roof. Yes, so we can also see there was like 3 minutes time between those two changes. We enabled the error rate or the promotional rate, which triggered the error rate, and after 3 minutes the problem was remediated. Yes, exactly. So, yeah. This was a little bit of Captain and Ansible. If you want to learn more about Captain, we have our website captain.sh. I've heard for some companies .sh might not work because they have like the browser thinks it's a script, but yeah, we came up with this before we saw that it might lead to some errors. But yeah, captain.sh is our website. Captain Project is our Twitter handle. So if you want to check this out, as I said, it's completely open source. And if you want to learn more about this self-healing applications without Captain, but only Dynatrace and Ansible, we have a lot of joint work going on between Dynatrace and Ansible. We have webinars, we have joint blog posts. Yeah, so if you want, please check this out as well. Thanks.